Okay, here's the last section of this semester. As soon as you're done cheering, you can go ahead and keep watching the rest of this video. Alright, so we're going to talk about the average value of a function. And before we get to that, I want to talk about what if you had a shape with a flat base. So here's an example of a sort of weird wiggly shape with a flat base. And you wanted to know what its average height is. That is, on average, how tall is that shape? Okay. Well, what does that mean? How could you figure that out? To me, it makes the most sense if I think about sort of smushing the top of the shape so that it's flat on top too. And that will sort of smush the stuff in the hills into the valleys. So the valleys will get filled in and the hills get flattened. Right, so you have a flat top now, and the stuff that was above that new flat top has sort of been moved over and used to fill in the valleys that were below that new flat top. So the orange stuff in this picture has been removed, and then it fills in the green area. What that means is the area that you're removing from above the blue line gets filled in below the blue line so that the orange area there is the same as the green area. The orange stuff you remove has the same area as the green stuff that was missing but now gets filled in. That means that the total area of the original shape you had is the same as the area of the new rectangle, because you shaved some off the top but you used that stuff to fill in what was missing, so the area is unchanged. That gives us a way of thinking about the average height of a shape like this. The average height of a shape like this is the height of the rectangle that you would make if you made a rectangle with the same base as the old shape and the same area as the original shape. Okay, so if you flatten it out, what's the height of that new rectangle? That's the average height of the shape. So now we're going to apply this to functions. Okay, here's a graph of a function. And it's f of x, and I'm going to be looking at the part of the function between x equals a and x equals b. Okay, so when I talk about the height of this function, what I really mean is the y value, and that's the value of f of x. That's the value of the function. So if we start asking about average height, what we're talking about is the average function value, the average f of x, in this case between a and b. And we'll write the average function value, f, with a little ave down below. So the average function value, from what we said before, is the height of the rectangle you would make with the same base, so base from a to b, that would have the area equal to the area under that function, so the area of the shape there. So it's the height of the rectangle whose base goes from a to b and whose area equals, well, we know what the area under the function from a to b is. That's just a definite integral. So I want the rectangle whose area equals that definite integral. This lets me write an equation. The average value times b minus a equals the definite integral. Why is that true? Well, what's on the left of the equal sign there, average value, that's a height, right? We said it's the height of a rectangle. And b minus a, well, that's just the width of the rectangle. So what I've got on the left is height times width of a rectangle. That's the area, and I want that area of a rectangle to equal the area that's the definite integral. So the average function value times b minus a equals this definite integral from a to b. Well, if you just divide that equation by b minus a on both sides, you get this. The average function value is 1 over b minus a times the definite integral from a to b of the function f of x dx. This equation is the definition of the average value of the function in between a and b, so on the interval from a to b. Okay, so here's a quick example. If I ask you for the average value of the function x squared between 1 and 3, all you have to do is use the formula. This is the sort of easy kind of math, right, where you just sort of plug in the numbers into a formula. I want the average value of the function from 1 to 3, so a equals 1 and b equals 3, so I do 1 over 3 minus 1 times the integral from 1 to 3 of the function x squared. This is an easy integral. The integral of x squared is x cubed over 3. Plug in 3 and plug in 1 and subtract. Do a little simplifying and I get 4 1/3. So the average value of that function on that interval is 4 1/3. What does that mean? That means if you graph the function here between 1 and 3, so the y values are 1 and 9, 4 1/3 is the height you would have to draw a rectangle whose base goes from 1 to 3, so that the area of that rectangle, the area of the blue rectangle, equals the area under the function. So that green shaded region equals the area of the blue rectangle. That's what it means. And that's how you find average values, and it's quite simple. Okay. There's one other thing of note in this section, and that's this thing called the mean value theorem for integrals. Now, we had a mean value theorem already. It was about derivatives. It said if you had a nice differentiable function on an interval, then the average slope between a and b had to equal an exact slope, a derivative, at some point between a and b. And this is similar. So the mean value theorem for integrals says if you have a continuous function f, and it's continuous on the interval from a to b, then there's some point c between a and b for which f of c equals the average value of the function. So f of c, remember, is the value of the function at this point c, and the average thing is the average value of the function on the whole interval. So all this says is if you graphed the function and you smushed it out flat, the height of the rectangle you would get is actually equal to f of something. Right? The height of the rectangle you get, which is the average value of the function, has to equal the exact value f of some number c between a and b. Okay. For example, in our previous example, where we found the average value of x squared on the interval from 1 to 3, what is c? Well, c, from the mean value theorem for integrals, is an x value between a and b, so between 1 and 3, and it has the property that f of that c equals the average value. Well, f of c in this case is just c squared, and the average value we already found, that's 4 1/3. So we're looking for c squared equals 4 1/3. That would mean c equals plus or minus the square root of 4 1/3, but we don't need the minus because c has to be between 1 and 3, so it has to be positive. So c is the square root of 13/3, the square root of 4 1/3. That's the c value that the mean value theorem says has to exist. For this particular example, we can actually find what c equals, but the mean value theorem says for any function, even really weird continuous functions, you could always solve an equation like this. F of c equals the average value. All right, that's it for section 5.5. I will see you in class, and then we'll be done with the new material for this semester. I'll see you there.